Let's go over some basics of plane geometry. First of all, of course, we know that this is a line. If I just draw that, that's a line. This is a point, right? So you have a point, you have a line, and you have a plane. When two lines intersect one another, they create a point. When two planes intersect one another, if I put another plane, we get a line. That's the intersection of two planes. And you can create shapes out of, different sort of plane configurations. And the first one we're going to talk about, of course, will be your quadrilaterals. So let's start right there. So let's talk about perimeter. When you talk about perimeter, you're going around a shape. And so you think about a square, right? If you have a square with a side of 4, that means that you just add up all the sides, and that's the perimeter of the square, right? Another way of saying it is just 4 times the length of each side. However, you can also think of the formula of a rectangle, the perimeter of a rectangle. You have a length, you have a length, you have a width, you have a width, and it's 2 times length plus width. So basically, if we add your length plus your width and you multiply by 2, that gives you the perimeter of a rectangle. So it's important that we know the perimeter of a rectangle, that we also understand all the different relevant formulas. So let's finish up with the perimeters, and then we'll move away from perimeter and talk about area. So the perimeter of a rectangle is 2 times length plus width. The perimeter of a triangle would be to just add up all the sides of the triangle. Now we look at the perimeter of like a circle, right? If we have a circle, we have a radius, right? And the perimeter is the same thing as a circumference, which is 2 pi r or pi d. And that is because the circumference of a circle, right, is again 2 pi r or pi d, and the radius is half of the diameter. So that's why it's the same thing. These formulas, especially 2 times length plus width and the circumference, are very good to know for doing problems that might have complex shapes involved. Let's look at a quick example. So imagine you have this shape. It looks like a semicircle here. So you have a semicircle and you have a rectangle. If I'm asking you to find the perimeter of this, then basically you have to find the length from here all the way to there, right? So imagine I just need some chalk and I want to know what distance, for whatever reason, just want to know my distance here. And then I want to know these lengths over here. Now, this is a unique one because if I give you this as 10 and 10, and then this as 5, right? So you just add these 3 numbers to get the length from here to here to here. But in order to find this over here, if this length is 5, that means, again, that's my diameter. My diameter is 5. But the formula says pi d. The circumference is pi d. But this is a semicircle, so you have to divide that by 2. So imagine if you have c is equal to pi times 5 over 2, right? Because you are looking at half of the circle, not the full circle. And then you add that to what you had when you had 10 plus 5, which is 25. That will then give you the perimeter around this shape. This shape would be called like a composite shape, a shape that has multiple shapes within it, right? So that's one way to think about it. We can look at multiple examples of other shapes. You can have a shape that is not even, like you have a shape like this. And you can, if I give you the different dimensions, you should be able to find the perimeter by adding up all the sides. Sometimes it gets interesting and creative with the kinds of situations you're given, but the principle is the same. There are times where you're better off splitting it into 2 separate shapes. You have one shape here, you have another shape here, and you find the perimeters and you add them together. Again, you find the perimeter looking at the values of what the value of each of the lines around the shape. That's the important thing with perimeter. So we need to know rectangles or squares. We need to know triangles. Again, just add up all the sides. Sometimes you might have to use the Pythagoras theorem to find the length of each side if you've been given only 2 sides, if it's a right triangle. And then a circle, you just remember it's 2 pi r, or the circumference is also pi d. Now, let's turn our attention to area. So we've looked at a quick review of perimeter. So let's talk about area. For the area, we're looking at similar shapes again. We have quadrilaterals, and then we have triangles, and we have, let's see, quadrilaterals, triangles, we have circles. So let's start with quadrilaterals. Length times width. You might be familiar with that for your rectangle. The area is length times width for the rectangle. We also have situations where you have something called a trapezoid. That is, the area would be 1/2 base 1 plus base 2 times height. Now, you can break a trapezoid into two shapes, right? You can break it into a triangle and a rectangle, and you can find the area that way. And the area, of course, is dealing with, look at the area here of this trapezoid. So we have trapezoid for parallelograms, right? For parallelograms, the principle is the same, base times height. So base times height of that parallelogram. For rectangles is length times width. And then for triangles, the area is 1/2 base times height. And I highly recommend, just either working with these formulas enough where they become something you're very familiar with, or, just memorize them, or you can work with them with practice and get used to them. So that's the one for your triangle. And then your circle is pi r squared, the area of a circle. So we've looked at some key formulas here. We have quadrilaterals, we have triangles, and we have circles. Pi r squared would be area of a circle. So those are relevant formulas for the area portion of this section. Let's look at an example of a trapezoid here. This is 5. And this is, let's give this 10. And this is, let's see, this is total here will actually be 15. So basically this would also be 5. So that would be a 45, 45, 90 triangle right there. How do we know that? Because if this is 5 and this is 5, then it's a special triangle, which is in a different video, but just want you to be aware that there is a special triangle where you have 45, 45, and 90, and that would mean that this side and this side will be equal. So, but let's say we have this trapezoid, okay, and you have the details. There's two ways we can solve this. Let's do it the first way. The formula is 1/2 base 1 plus base 2 times height. The other way would be to find the area of the rectangle and the area of the triangle, right? If we split it into two shapes. Let's try both approaches. The first one here, 1/2, the base 1 is 10, the base 2 is 15, and the height is 5. So that's 1/2 of 25 times 5. So that's 125 over 2, right? So that's 62.5 for the area, units squared. The other approach here would be, so imagine you have this triangle here. So you have 10 times 5. So that's the area of that, length times width. And then 1/2 base times height. So what is my base of this triangle? It would be 5, right? What is my height? It would be 5 as well. So 50 plus 1/2 times 25. What is half of 25? That's 12.5. That also equals 62.5 units squared. See, the beauty of math is whatever approach you're using, you could still get the same answer. You can either use the formula that you memorize for the area of a trapezoid, or you can use the knowledge of splitting the shape into two and trying to add the values together. Either way would give you the answer that you need. So make sure that you get familiar with what you want to do, or if you forget what you want to do, when you get to the question, remember that there's multiple ways to approach it. So we took the trapezoid and we treated it as a composite shape, and then we broke it down into two smaller shapes and found the area of each one and then added the areas together. And that works. That is a good approach to use. Before we wrap up, let's talk about dimensional situations. So let's talk about volume. The three shapes that I want you to really keep in mind. You have your cylinder, you have your rectangular prism, and you have so cylinder, rectangular prism, and the sphere. Let's talk about those ones, because out of the sphere we can get a lot of different types of situations. And so the cylinder, we talk about the volume of a cylinder, which is actually the area of the base times the height. And in your cylinder, you have pi r squared times h then, right? Because you have a circle in the base. So that is the area of the base times the height. And we know that the area of a circle is pi r squared. So that's the volume of a cylinder. The volume of a prism, a rectangular prism, is length times width times height. This is just a sketch of a rectangular prism. And the volume is length times width times height. So that's the volume of a rectangular prism. And the volume of a sphere is 4/3 pi r cubed. So It's good to know that. I mean, again, these are formulas that you might have learned in middle school. You can keep reviewing them. But, or you could we have several formula sheets that you could use, or you could go online and look this up and just have a document with all the formulas in one place that you can refer back and as you keep using it over and over again, you get more familiar with it. The surface area of a rectangular prism, by the way, all you would need to do is to find the area of each of the faces. That's what you need to do. And then multiply them by 2, essentially. Because you have your length times your width for one of the rectangles, your height times your width, and then your length times your height. And then you multiply each of those by 2. The surface area of a cylinder, you would basically have 2. You have 2 of these, right? So 2 times the pi r squared. So you have 2 times pi r squared, right? Because each of the circles is pi r squared. And then you add that to the circumference times the height. So times circumference times the height. And the height, of course, will be there. So 2 times pi r squared and then plus circumference times the height. Most times I see the volume focus on the ACT practice. But just something for you to keep in mind. The surface area of this one is given for the cylinder. And then the last one, the sphere. Sometimes they will give you these formulas, but it's just nice to know how they work. Right? If I give you the radius, you just plug it into this formula and simplify. That's what you're doing. You just need to know how to plug in those values. The surface area here would be 4 pi r squared. That's the surface area. Now, if you've taken calculus, you might see how we derive the surface area from the volume. That's another topic. Calculus is really exciting, and I hope that you stick around and do calculus as well. Even if you don't want to be an engineer, it's just a beautiful field to study, and we can talk about that in a different video. So these are the formulas for the volume of a cylinder. We have a rectangular prism, and we have a sphere. Very good formulas to know, very good formulas to be comfortable with. Let me know if you have any questions as you go through any of these. Remember, if they give you the height and the radius, you just plug it in and you'll get the answer that you need. I will leave you with the cone, actually, which is 1/3 area of the base, so pi r squared times height. That's the volume of a cone, and that's just extra for you to keep in mind. Otherwise, again, get a page where you're writing all the formulas that you need to be familiar with and at least be comfortable using them, because sometimes they will give you the relevant formula for the thing in question. So just make sure you're familiar with how to use it. Thanks for watching this and keep up the good work.